Electron configuration. Electron configuration is basically the distribution of elements in atoms within orbitals. Using this method, we can predict where electrons are within the atom, even though they are constantly moving. The picture in the middle shows that the big number represents the sublevel, the letter represents which orbital it is in, and the exponent represents the number of electrons in that orbital. The chart shows the 4 different sublevels or suborbitals. The s level has 1 orbital and can hold up to 2 electrons, 2 per orbital. The p sublevel has 3 orbitals and can hold up to 6 electrons. The d level has 5 orbitals and can hold up to 10 electrons, and the f level has 7 orbitals and can hold up to 14 electrons. We can use the periodic table as a way to do electron configuration, but first we have to set it up. Shown here is the s sublevel. You can see that within the purple there are 2 electrons, aka elements, in each row. Notice that it is the same number as on the chart on the previous slide. You can also see that the s levels are numbered vertically. Here is the d sublevel with 10 electrons or elements in each row. Once again, it is labeled vertically, starting with 3 this time. Next is the p orbital with 6 electrons or elements in each row. It is labeled starting with 2. Also, P should have popped up before D, sorry for that mistake. Lastly is the F suborbital. It has 14 electrons and begins counting with 4. Now we are going to begin. We are going to use scandium today. We read the periodic table like we read a book, from left to right and from top to bottom. This means that we begin with 1s. Since we are trying to get all the way down to scandium, you can see that the 1s block fills up, so we can write 1s to the power of 2. Next is the 2s block, which also fills up, so we write 2s exponent 2. Next, since we read like a book, is 2p, which also fills up, because once again, we are going all the way to scandium. Next is 3s, and we still have to keep going, so we write 3s squared. Now we have reached 3p to the 6th, and then 4s squared. We have finally almost reached scandium. We write 3d, and since scandium is the first element in that sublevel, we write 3d to the first. This line of writing is our electron configuration. Now we are going to learn the shorthand or noble gas method. We are going to use scandium again. This time we will look at the noble gas that comes before our element. In this case, it is argon. We write argon in brackets and do the same method as last time, but starting from argon instead of hydrogen. So 4s fills up and we give it an exponent of 2 and then 3d to the first since we have already reached scandium. That's all there is to it. Thanks for watching.